Question number 3.78. Here a figure is given. This is point A. So near to point A, lying on the boundary between glass and the vacuum. So this surface is vacuum and inner one is glass. So let's assume that we have like dielectric. Okay. So its permittivity is epsilon. Okay. The field strength in vacuum is equals to 10 volt per meter. And the angle between vector E naught and n cap is alpha naught, and that is equals to 30 degrees. Find the field strength E inside the glass near to this point A, number 1. So we have to find out E inside the glass. Number 2, the angle between vector E and n. This means the normal to this surface and the electric field which is E is making here. This angle alpha we want to calculate. Okay. As well as surface density of the bound charge at point B. It means bound charge also needs to be calculated here. So let's see. Basically, this problem belongs to a boundary value problem. Okay, boundary value problem means when an electric field passes from one region to another region, and that boundary is boundary between dielectric and vacuum, then suppose electric field is coming at certain angle. So there would be two components. One is tangential component, another is normal component in medium 1. Similarly, there will be two components. One is tangential component in medium 2 and second one is normal component in medium 2. Okay. So if we'll apply the boundary condition for the field, then tangential component remains unchanged. Okay. But the normal component in medium 1 is equals to epsilon times normal component in medium 2. Okay. So we'll proceed by taking these conditions into consideration. Now see, here this electric field E naught is making an angle alpha naught with the normal direction. So from here we can find out the normal component in medium 1. Here we are taking vacuum as medium 1. So this component would be E naught cos alpha naught. This component. And the normal component which will become tangential for that, it is E naught sin alpha naught. Similarly, we can write the components here that E sin alpha and E cos alpha. So En1 is E naught cos alpha 1 and Et1 is E naught sin alpha naught. For second medium, En2, this is for glass, is E cos alpha and Et2 is E sin alpha. So if we'll apply this boundary condition between dielectric and vacuum, then we can write that E naught sin alpha naught is equals to epsilon. Okay, we are writing for tangential component. So it is E sin alpha. And for normal component, E naught cos alpha naught is equals to epsilon into E cos alpha. Okay. So as we want to calculate the magnitude of electric field in second medium first of all, so we can do manipulation here. So from here we can write this from this equation. E cos alpha is equals to E naught upon epsilon into cos alpha naught. Right. So we just need to square and add equation number 1 and equation number 2. So from here we'll get that magnitude of the electric field is equals to under root this component is square plus this component is square. So this is E naught square sine square alpha naught plus E naught upon epsilon whole square cos square alpha naught. Okay, so we can substitute value if we want that E naught is 10 volt per meter, so we can take out E naught square from this bracket. So this is 10 under root sine alpha, sine 30 is 1 over 2 and its square is 1 over 4 and cos 30 is root 3 by 4, so its square is 3 by 4 into epsilon, the permittivity of this medium. Okay, so here we can write 5 under root 1 plus 3 upon epsilon. This is magnitude of electric field. And if we try to figure out the angle subtended by this electric field with the normal, then just divide equation number 1 with the equation number 2. So from here we'll get tan alpha, this divided by this, and E naught and E naught would get cancelled. So we'll get tan alpha naught upon epsilon. And tan alpha naught is known that tan 30 and tan 30 is root 3. 1 over root 3. So 1 over root 3 epsilon naught. This is value of tan alpha, where alpha is angle subtended by the electric field vector in second medium. Okay, it was the first part of this problem to find out electric field in second medium and its angle with the normal. Now the second part is total bound charge density induced near to A. So we know that the electric field density D is equals to epsilon naught into epsilon into E. Okay, and bound charge generated in a dielectric due to polarization, and this charge density is equals to polarization, and that is equals to dN minus epsilon into En, right? So from here we can substitute value of dN, that is epsilon naught, okay, into epsilon into En. En is E naught cos alpha. E naught cos alpha, the normal component we already calculated from the medium one. And for second medium, this must be divided by the epsilon. So from here we'll get, okay, this is epsilon naught cos alpha for medium 1, and for medium 2 this is epsilon naught upon epsilon into E naught cos alpha. Okay, so from here we'll get, it will take out the common factor, that epsilon naught into E naught cos alpha naught, I must write, into 1 minus 1 upon epsilon. Okay, so by simplifying this expression we'll get bound charge density, which I am writing here, that delta dash is equals to epsilon minus 1 upon epsilon into epsilon naught E naught cos alpha naught.